In this video, you will learn how to use the plot and regression features of this calculator. The following examples will specifically involve linear and exponential regression. For any other types of regression, the steps are the same. Before we begin, we will use the mode key so all of our answers are rounded to 4 decimal places. So we go to the mode key, select it, and remember we need to go to the float. So we move down, and then since we're rounding all of our answers to 4 decimal places, we need to move the cursor over to 4 and then select enter. Now we get out of this by going second function and then quit. For example number 1, we would like to plot the following data points as shown to the right. Find a linear function that best fits the data points. Find the correlation coefficient, and then graph the linear function including the data points. So to plot the data points, we need to turn the plot mode on. Now the simple way to turn the plot mode on is you simply go to y equals, and then you can see plot 1, so you just move the cursor up and then select enter. So that turns plot 1 on, and you can see that plot 1 is highlighted. Now another way to do this is if you go to second function and then stat plot, so you hit the y equals key, you can see that plot 1 is turned on and plot 2 is turned off and plot 3 is turned off and so on. Now if you select enter for plot 1 and you wanted to turn that off, you would move the cursor over to off and then select enter, and there are some other details here that we'll discuss in example number 2. But for now, let's just get out of this screen and go second function quit, and you can make sure that the plot is turned on by just hitting the y equal button and then make sure that the plot 1 is highlighted. Okay? So let's go ahead and enter in the data. So we go to stat, and then we go to edit. So that's number 1 there. Select enter, and then we're going to enter in the data. So we have 3, enter, 7, enter, 13, 21, 27. Now, the x values, of course, here are represented by L1, and then the y values will be represented by L2. So we move the cursor over and enter in the y values. So we have 2, enter, 4, enter, 9.4, then 10.6, and 15.9. Select enter. Now if you needed to edit any of these values, if you made a mistake or you inputted an extra value, you can move to the data point where you need to edit, and you can either select delete or you can simply type over that particular number. Like if this should have been a 15, you would just simply go 15 and then select enter. So we wanted to plot the data points, and here are the data points. So we would go to zoom, and we're looking for zoom stat. And there it is, number 9, zoom stat. So we select enter, and here are the individual points that are represented by the data shown on your screen. Now the second part of this question, part B, is to find a linear function that best fits this particular data. So what we're going to do is we're going to go to the stat mode, and then we're going to go into the linear regression area. So before we do that, we need to turn on the diagnostics, and the reason why we're going to do this is because in part C we're asked to find the correlation coefficient, and unless your diagnostics are turned on, it will not give you the value for the correlation coefficient when you do your linear regression. So let's do that by going to second function, and then you can see down here it says catalog. So we'll select 0, and then these are all the different types of functions that are built into the calculator, and they're listed in alphabetical order. So we're going to go ahead and scroll down till we find the D's, particularly diagnostic on. And here they are, diagnostic on and diagnostic off. So let's move the cursor up. So there's a little cursor there, and it's on diagnostic on. That's what we want. We select enter, and then enter again, and it says that it's done. So now the diagnostics are turned on. So let's go back into the stat mode, and we want to move over to calc. And then we're looking for linear regression, and here it is. And remember that the equation of a linear function is y equals mx plus b, where the m is the slope and b is the y-intercept. In this case, the a is represented as the slope. Alright, so select number 4. Since the last part of this question is asking us to graph the linear function and include that graph with the data points, we would like to make this process streamlined. So what we're going to do is we're going to tell this to find the linear function, and then we're going to tell it to put that particular equation into y1. Okay? And remember, y1, let's hit y equal, is right here. So it's going to take the answer and put it right here. So let's get out of it, second function, and quit. So what we need to do is we need to select vars, and we want y vars, so move the cursor over, and we want function, so select enter, and we want y1, so select enter. So now it's going to find the linear regression of those particular data points, and it's going to take that linear function and enter it into y1. So let's select enter, and here's our results. So the equation is going to be y equals 0.5481x plus 0.5963. So here's our a value and our b value. And now the correlation coefficient is 0.9769. And that's because the closer that the r value is to 1, that means that your function fits the data pretty well. Okay, so the further you get away from 1, then you don't have really a good fit of your function to that particular set of data points. So in this case, this is very close to 1, so we have a good fit. Alright, so the last part here, it says to graph the linear function including the data points. Well, if you look in the graphing mode, y equals, you can see here's the equation that it was automatically put into y1, and we told it to do that. So all we really need to do is just simply hit graph, and it graphs that linear function, and it's showing the data points along with that linear function. So this concludes example number 1, and we're going to do a similar example for example number 2, but with a couple sets of data. So let's go ahead and clear the screen, and we'll clear this information again. Now for example number 2, we would like to plot the following data points, which are shown to the right, and the data points are going to be such that the x values are going to be constant and what's going to vary are the values for y1 and y2. You can look at this as an experiment to where the x values are fixed, and then we get different measurements for the column there that you see in y1 and different measurements for y2 on the second experiment. And then part B, we would like to find an exponential function for each set of data points. So in other words, we want to find a exponential function for x and y1 and then for x and y2. And of course we're going to find the correlation coefficient for each of those functions. And then we would like to graph both of the exponential functions, including the set of data points. Alright, so there's a few things that we need to do here. First of all, let's go ahead and we need to clear the data out of memory. So if we go back into Stat and then under Edit, here's the old data from example number 1. Now we could simply just, like I said before, hit the delete key and it deletes each of the values. But let me show you another way to delete everything at once. If you go to Stat and then number 4 says Clear List, if you select number 4 and then you're going to clear the list L1 and L2, you would go second function, and then you can see right here it says L1, so we hit that key, and then comma, and then go second function, and then the other list is L2. So we'd go second function and then L2, so we hit that key. Alright, and then we select Enter, and then it clears the list. So if we go back into Stat and then under Edit, there shouldn't be anything there. Now, the other thing that we would like to do is, since we want to plot the data points, and there's two sets of data here really, there's x and y1 and then there's x and y2, we need to turn plot 1 on and plot 2. Now remember that plot 1 is already on, and we can check that by hitting y equals. Let's just go ahead and clear that function out of there right now. We don't need it. So there's plot 1, and then we need to turn plot 2 on. Now remember that we can go up and then move the cursor over and then highlight plot 2 and then select Enter. But for this particular example, since there's two sets of data, we need to differentiate between each set of data points. So in other words, we don't want to see the same type of symbol for the first set of data and for the second set of data. They need to be different so we can tell which is which. So where we do that is we do that under Stat Plot. Remember, there's a little bit more details under Stat Plot. So we'd go second function and Stat Plot. Plot 1 is turned on. Okay, that's good, but let's select Enter. And you can see that the first set of data is that the x values are represented by L1 and the y1 values are represented as L2. And that the mark for that particular set of data is going to be a little square. And then it's also shown that the type of graph that it's going to be on a scatter plot. And that's what we want. We're going to use the scatter plot right here. Okay, the XY scatter plot. So this looks good. Now if we move up to plot 2 and then select Enter, okay, we're on plot 2 and we need to turn it on, so let's select Enter. So now it's turned on. You can see that the highlighted part is on the on, and we want it on the XY scatter. That's fine, except now the x values, they will be the same under L1, but the y2 values are going to be under L3. So let's move down and change this to L3. So we go second function and then here's L3. So there it changed it to L3. Now remember that the first set of data, the x and y1, was represented by a little square. So let's change that to a plus symbol for the second set of data. All right, let's move the cursor down and move that over and select Enter. Okay, so the second set of data for L1 and L3 is going to be a plus symbol. All right, so let's get out of this. And if we just go back to stat plot, I want to show you something, second function stat plot. You can see here an overview. Plot 1 is on. The data is L1 and L2, so X and Y1. It's on scatter plot, and it's going to show the data by a little square. Then plot 2 is turned on. It's an XY scatter plot. The data is going to be X is going to be represented by L1, and then the Y2 is going to be represented by L3, and this data is going to be shown as a little plus symbol, and then plot 3 is turned off, and then plot 4 and so on is turned off. So let's quit out of this, second function and quit, and let's go ahead and enter in the data. So we go to Stat, and then remember Edit. So select Enter. And the X values are going to be 2, Enter, 5, Enter, then 10, 20, 27, and then 32. Let's verify that. 2, 5, 10, 20, 27, and then 32. Okay, and let's move over. Now L2, remember, is represented by Y1, so that's 5500. Enter, then 3700. Enter. And 2550, 2550, enter, 1300, enter, 715, and finally 470, and then enter. Okay, then we're going to go over to L3, and remember that this is represented by Y2. So that's 5,972, 5,972, enter, 3,200, enter, 2,100, 1,596, and 905, and finally 301, and then enter. Okay, so here's the X and Y1, and then the X and Y2. So here's basically two sets of data. Now remember that we want to plot the data points. So remember that we need to go to Zoom, and then we're looking for Zoom Stat. And as I recall, that was number 9. And there it is, Zoom Stat. Select Enter. And then remember that under the stat plot, we saw that the plot 1 was the little square boxes, and that was represented by the X and Y1. And then the little plus symbols represented the X and Y2 for plot number 2. And let's go ahead and get out of this screen. So second function and then quit. Now remember, we want to find an exponential function that best fits each set of the data points. So we go back to Stat, and we want to go to Calc, and we want exponential regression. And let's scroll down here, and we're looking for exponential regression, and there it is. It's EXPREG. So we select Enter. Now again, remember that we want to streamline the amount of steps here, and since we want to plot these points and see the actual graph of the exponential regression, we can go ahead and automatically put the answer into y1, and then for the second set of data points we can put the answer into y2. So what we're going to do is we need to represent this for y1. So the way to do that, recall, is we go to vars, and then we go to yvars, and then we want function, and then we want that to be represented by y1, so select enter. So we have exponential regression for the first set of data points, which was the L1 and L2, and it's going into y1. So we select enter, and then here's our equation for exponential regression, and that is y equals a times b raised to the x power. Remember, that means raised to, and then whatever power, and here it's the x power. Okay, that's the variable. So the a value is 5,911.6219. The b value is 0.9245. And then here's our correlation coefficient, is negative 0.9979. So that's an excellent fit because the absolute value is very close to 1. Now if we look under y equals, we can see that function is listed right here. So 5,911.6219 times 0.9245 raised to the x power. Okay, now we're going to go back to stat, and we're going to do the same thing. We're going to go over to calc, and then we want to find exponential regression. And there it is, 0. So let's hit 0. Now the default is that you're going to find exponential regression for L1 and L2. Now we don't want to do that. We just did it before for the first set of data points. So we want to find the exponential regression now for the second set of data points, which was L1 and L3. So we need to tell the calculator that because we're not doing the default. Remember, the default's L1 and L2. So we need to specify, so we go to second function L1, and then comma, second function L3. And then we want to take this answer, okay, the equation for the exponential regression, and then put it in the y equals under y2. So we need to go comma, and then remember we hit vars, and we go to yvars, and we want function, and then we want that under y2, so we select number 2, and then here's the format, and then we select enter. Now remember, we had the diagnostic turned on, so we are getting the correlation coefficient along with the exponential regression values. So remember, the equation is y equals a times b raised to the x power. So in this case, a is 5,920.9195, and b equals 0.9219, and we have a correlation coefficient of negative 0.9560. Once again, the absolute value of this correlation coefficient is close to 1, which makes it a good fit. So if we look under y equals, we can see that here is the second equation for the exponential regression of the data points x and y2, and this is the exponential regression for x and y1. Now it looks as if the correlation coefficient is a little bit better for the first function right here compared to the second. It's not really that far off, but it's a little bit better fit. And you can see that on your screen to the right, the correlation coefficient, let's go back here, of the first answer that we had, you can see the correlation coefficient's a little bit closer to 1 compared to the correlation coefficient of our second answer of the exponential regression. So finally, let's go ahead and graph each one of these. So we already have each function inputted, so we just simply hit graph. And there it is, the first function. You can see this means the calculator is busy thinking. And there it's graphing the other line. Now these are very close together, and you can't really see it here. So let's go ahead and do a zoom. And remember, zoom box. So let's select enter. And there's the cursor right there. So let's move it over a little bit. And let's zoom in on a couple of data points. Let's move up a little bit. Select enter. And then we'll move down. And then we'll move over. Let's move down a little bit. Trying to get 2 data points here in the box. So let's move down a little bit further. Right there. So let's zoom in on this area, and you should be able to see 2 different lines. So let's select enter. So there's the first one for Y1. It's going through, remember Y1 had the little boxes, and then here's Y2. So you can see it's separated a little bit. Okay, and then if we zoomed in a little bit further, if I select zoom and then zoom box, remember we can zoom in even closer. So let's move the cursor down there and select enter, and then I'll move up and then move over a little bit. Then I'll select enter again. And then you can see that the lines are definitely separated. So let's get out of this screen, second function, and then quit. So both of the functions that we have for each set of data points is the y1 will equal 5,911.6219 times 0.9245 raised to the x power, and then y2 for the second set of data points will equal 5,920.9195 times 0.9219 raised to the x power. And remember that the correlation coefficient was a little bit better for y1 rather than y2. So one thing this can tell us about this set of data points, or for the experiment that we were sort of setting up here, is that we definitely can conclude that for the set of data points x and y1 and x and y2, that both of those sets of data are definitely suited for an exponential type of curve. This concludes the video on using the plot mode and the regression features of this calculator.